Hello and welcome. Today, I'm going to share with you a case study using logistic regression. I designed it so that it will help you to develop skills in statistical modeling. What is logistic regression? Logistic regression is a model used to model probability of a categorical variable. It estimates the log odds of the event occurring as a linear function of the predictors. As you can see from the formula, the log odds of the dependent variable is linearly related with the linear function of the independent variables. And this is one of the assumptions of logistic regression. Another assumption of logistic regression is multicollinearity problem. You need to check if one independent variable is expressed in terms of another independent variables. For example, if x1 is expressed in terms of 3 times of x2, what you need to do is either you need to merge them or you need to delete one of them. In the statistical analysis, we can apply classical and Bayesian version of logistic regression. Normally, we use classical when we want to infer a parameter based on only the data we have, whereas we use Bayesian when we want to infer a parameter based on the data we have plus some prior information, which is already known. And the prior information may follow a uniform distribution, normal, Cauchy, or some other distribution. Normally, we have two variables, dependent and independent variables. For example, let's consider the dependent variable is graduation with two outcomes, success or failure, specifically graduate or not graduate. And we may have many independent variables. Some of the independent variables can be age, entrance exam score, first year cumulative GPA, and preparatory average result. So how do you interpret the result? You can use the beta values or the odds ratio. Odds ratio is the exponential value of the betas. We are going to use 3 examples so that you will interpret your results similarly. For entrance exam score, with odds ratio of 1.022, which is the odds ratio is greater than 1, indicating increased odds of the outcome, we interpreted it as a 1-point increase in entrance exam score increases the odds of graduating by 2.2%, holding other variables constant. The percent is calculated as the odds ratio minus 1 if it's greater than 1. If it's less than 1, 1 minus the odds ratio times 100%. That's how you calculate the percentage. And similarly, you also calculate the percentage for the other variables. So let's consider another independent variable, which is continuous with odds ratio 0.665. And we interpret it for each year increase in age, odds of graduation decreased by 33.5% while holding other variables constant. When we have a categorical variable, then we compare the categories with a reference category. In this case, students with cumulative GPA below 2 are about 88.8% less likely to graduate compared to those with cumulative GPA greater than 2, holding other variables constant, because that's the reference category. Okay, I'm going to show you how you are going to do analysis using SPSS and R. Using SPSS, I'm going to use a data which I took it from the internet. The objective was to identify factors for the admission to postgraduate study. There are 3 independent variables, 2 of them continuous, 1 is categorical with 4 categories. And please don't forget to put target and to indicate that it is dependent variable. For independent variables, Under the role, you need to assign input, 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 indicating they are independent variables. And then what you do, you go analyze, regression, binary logistic, and then under the box dependent, you click the dependent variable. Under the covariates, you select all the independent variables and then move them to the covariates box. Don't forget to define any categorical variables. We have only one here. And then don't forget also to indicate the reference category. The default for SPSS is the last category, for R is the first category. In order to have similar results, we can change the reference category to first. Don't forget to click change and then check here. It says first. Is correct. Continue. We need also to click on options and then check the checkbox for goodness of fit test. And we can also click on the confidence interval for the exponential of the betas. And you can also include iterative history and others also. Continue. Okay, this is the result. So the very important thing is the following. You need to consider tables after block 1. And this table is very important. Model summary table is important, indicating the percentage of the dependent variable explained by the independent variables. The Hosmer-Lamont test is important. You need to put it in your report, indicating the model adequacy. Classification table is important, and variables in the equation is also very important. Similarly, we can also do the analysis using R. The first thing is you need to read the data, either from Excel or SPSS. Then this is how the data looks like. Don't forget to define the categorical variable by considering as factor, rank, and then model using logistic regression. GLM is generalized linear models, but the family is binomial, means binary logistic regression. We run the summary. In here, if you see, the 95% confidence interval is not included. And also, the odds ratio is not included. So you use a different code for that. This is the code for odds ratio, and this is for confidence interval. Now, for you, the big question is, why do some students graduate on time while others not? Is that because of their previous academic performance? Or is that because of the financial or administrative factors, or preparation, or demographic variables, or something else? So you are going to work on a case study using the following data. This data was taken from Kaggle. Kaggle is a platform where data scientists do statistical analysis, for example, by using Python. And so you are going to use logistic regression to model graduation status of this data. And the data is uploaded to GitHub. And the link is shared with you. And the description of the data is also provided to you using a PDF file. So you can see what each variable means. And the data is provided in Excel format and also in SPSS format. And so then you will learn how to select appropriate predictors. You will also learn how to interpret the results. And then you will also learn how to communicate statistical results effectively. We have 21 independent variables. We group them into 3 thematically, and you will try to answer how do demographic and socioeconomic predictors affect graduation status, and try to answer questions: do institutional engagement or financial factors impact students' graduation? And you will try to answer, are early academic success strong predictors of graduation status? And please explore using descriptive analysis, model the data using logistic regression, and you can use SPSS, R, or Python. So this is what is expected from you. Best of luck, enjoy the challenge, and see you next time. Thank you and bye.